Hello guys, welcome to the class of Renewable Energy Technology. I am Izar Hussain in front of you. So basically today's lecture is about a resource that is basically used in renewable energy, that is wind energy. Because in last lectures we covered about solar energy. So in this portion basically we are going to start wind energy. That is basically a main resource of renewable energy. So before going to that, uh, wind turbines and that the main basic concept is of wind. So I'm going to share the screen with you guys, and that is basically our PowerPoints. Okay, okay. So today's lecture is basically about wind energy. So first of all, how does wind forms? Means first of all, there is question: how does wind forms? So wind farms basically wind is air in motion. Means when air is in motion, then that is basically what? That is basically wind. So wind forms when the sun heats one part of the atmosphere differently than another part. This causes expansion of warmer air, making less pressure where it is warm than where it's cooler. Air always moves from high pressure to lower pressure, and this movement of air is wind. Basically when air moves from high pressure to low pressure, means from pressure to low pressure, when air moves, so that movement of air is basically known as wind. So during the day at a coast, the sun heats the air above the land more quickly than the air above water. The warm air over the land expands and rises. Cooler air from the ocean moves towards the land to take the place of the rising air and makes a sea breeze that cools beach girls in the summer. The image that is basically in front of you in the screen, that is basically the circulation of air. Let's suppose there is lower pressure, means the red L, and then there is basically higher pressure. So now when there is high temperature, it means that there is high pressure. So when air moves from higher pressure to lower pressure, then the temperature is basically lower at that place. In this style, basically air moves from high pressure to low pressure, and that movement of air is basically known as what? Wind. So when air moves from high pressure to low pressure is basically what? Wind. Okay, so this is basically a little bit wind is air in motion. Wind forms when the sun heats one part of the atmosphere differently than another part. Oh guys, so now what is wind? So that is basically important, that what is wind. So air may not seem like anything at all. So in fact we look right through it all the time, but during a windstorm air rarely makes its presence known. Normally we are not able to see or watch wind, but we feel wind. But when there's a windstorm, so we really makes its presence that there is wind. Okay, so wind is described with the direction and speed. So we can describe wind with the direction and the speed of the wind. The direction of the wind is expressed as the direction from which the wind is blowing. Means direction from the wind is blowing, that is direction of wind. For example, easterly winds blow from east to west, while westerly winds blow means from west to east. So winds have different levels of speed, such as breeze and then gale. So depending on how fast they blow. So wind speeds are based on the description of winds uh, in a scale called the Beaufort scale, which divides wind speed into 12 different categories from less than 1 meter per hour to more than 73 mph. So that is basically we can describe our wind. So when there is warmer air, so warmer means heat, when sun give the heat to that particular air, so that basically warmer air. So the warmer air means there is basically high pressure. So that wind moves from high to low pressure as shown in the screen. So at the right times or the cloudy season, there is basically cold air. So means air moves from high pressure to low pressure. That movement of air is basically known as what? Wind. Okay. So wind is moving air and is caused by differences in air pressure within our atmosphere. Air under high pressure moves towards areas of low pressure. The greater the difference in pressure, the faster the air flows. So now basically wind generation. What are basically means how wind generates? So first of all, the main reason of wind generation is basically uneven solar heating. Basically, wind results from the movement of air due to atmospheric pressure gradients. Atmospheric pressure gradient means the change in pressure. So basically wind flows from regions of higher pressure to regions of lower pressure. Okay. So the larger the atmospheric pressure gradient, the higher the wind speed, and thus the greater the wind power that can be captured from the wind by means of wind energy uh, converting machinery. So when there is high wind, so the converting machinery means our turbines generates a lot of energy. So how wind generates? So first of all, there is uneven solar heating. So wind generates by the uneven solar heating. Among all factors affecting the wind generation, the uneven solar heating on the Earth's surface is the most important and critical one. The unevenness of the solar radiation can be attributed to four reasons. So basically, uneven solar heating is due to four main reasons. And due to that, basically wind generates. So wind generation is dependent upon the uneven solar heating. So there are four reasons. First is that the earth is a sphere. As shown in this figure, earth is a sphere. Okay. So when this earth revolving, there revolves around the sun. So earth is sphere when this earth revolves around the sun. So the uneven solar radiation on the earth's surface is the most important. Let's suppose revolving around the sun in the some plane as its equator. So now at the equator there is basically direct hitting of the sun rays. Okay. So because the surface of the earth is perpendicular to the path of the sun rays at the equator, but parallel at the sun rays at the poles. Now at the poles there are basically parallel, at the equator there is basically perpendicular to the sun. Okay. So the equator receives the greater east amount of energy per unit area. Okay. So with energy dropping off towards the pole, due to the spatial uneven heating on the earth, it forms a temperature gradient from the equator to the poles and a pressure gradient from the poles to the equator. So means there is changing in the temperature at the equator and at the poles as shown in the figure, and there as well as there is basically change in pressure from poles to the equator. So that is basically hot air with lower air density at the equator rises up to the high atmosphere and moves towards the poles, and cold air with higher density flows from the poles towards the equator along the earth's surface without considering earth's self rotation and the rotation induced Coriolis force. So, so from the poles to the equator, basically there is the change. There is a pressure gradient. Or there is basically change in pressure. So that's why air moves from high pressure to low pressure. So that is basically the blowing of air. You can say that if there is movement of air from high pressure to low pressure, that is basically known as wind. So this wind is generates due to the uneven solar heating. So this is the first reason of uneven solar heating. That is basically what spherical shape of our earth, and earth rotates around the sun. Okay, second is what? Second, the earth self-rotating. Now earth rotates itself. So earth self-rotating axis has a tilt of about 23.5 degrees, okay, with respect to its ecliptic plane. So it is the tilt of earth axis during the revolution around the sun when Earth revolves itself, or you can say that rotate, self-rotating, Earth in self-rotating form, there is basically 23.5 degrees. Okay, tilt of 23.5 degrees. So when it is the tilt of the Earth's axis during the revolution around the Sun that results in cyclic uneven heating, causing the yearly cycle of seasonal weather changes. So over changes in weather means there are four weathers in Pakistan, let's suppose. So there's summer, there's winter. So that's basically due to the rotating of Earth. So due to this uneven solar heating, so there is basically change in pressure and air is blows. So that is basically formation or generation of wind. So now the third reason. First reason is what? The sun hits at equator and the poles, the change in pressure gradient, and this one Earth rotates itself. So there is a tilt of axis, that is basically second. And the third reason of uneven solar heating is basically what? Surface is covered with different types of materials. Okay, different types of material, such as vegetation. Okay, so this suppose vegetation, and then there is rocks, there is water, there is ice or snow, there is basically you might say that sand. So each of these material has different reflecting and absorbing rate of solar radiation. So if there is a different rate of solar heating, or you may say that absorption or reflection, so that is basically causes the different rates to solar radiation, so leading to high temperature on some areas. Okay, example deserts, and low temperature on other, like let's suppose ice lakes or snow areas. So even at the same latitudes, so if there is different in temperatures, it means that there is different in pressure. Okay, so this is also a reason of uneven solar heating. So now the fourth and last one is basically of uneven solar heating is basically of solar radiation is due to the Earth's topographic surface. There are a large number of mountains, valleys, hills, etc. on the Earth, resulting in different solar radiation on the sunny and shady sides. So in some place there is basically hills, there are some valleys, and then there are mountains. So due to that, basically there is difference in the radiation of sun. So you may say that the reason for uneven heating of solar radiation is due to the Earth's topographic surface. Topographic surface means large number of mountains, valleys, hills, and etc. So these are basically main four reasons of uneven solar heating, and due to that there is basically change in pressure gradient and temperature. So that's why basically our air moves, and the motion of that air is basically known as what? Wind. So you can say that wind can be generated due to the uneven solar heating. Okay, now after uneven solar heating we have uh, Coriolis force. So it's important. Coriolis force, the Earth's self rotation. Okay, in this picture basically there are some different cells, so I can explain each and everything. So the Earth's self rotation is another important factor to affect wind direction and speed. Okay, the Coriolis force, which is generated from the Earth's self rotation. Okay, Earth's self rotation also causes uneven solar heating, but the Coriolis force is also due to the what? Due to the, yes, self rotation is a factor to affect wind direction and speed, which is generated from the Earth's self rotation. Okay, the Coriolis force is generated due to the self rotation of Earth. So deflects the direction of atmospheric movements. In the north atmosphere, wind is deflected to the right, and the south atmospheric to the, yes, to the left. Okay, so in this picture, if you divide this particular screen into left and right, so you may say the left and right, and then north and south. So if there is a north atmosphere, wind is deflected to the right, and in the south atmosphere to the left. So the Coriolis force depends on the Earth's latitude. It is zero at the equator and reaches maximum values at the poles. Means at equator it is zero, It rotates in the equator at the zero, and at the poles is basically maximum. Okay. In addition, the amount of deflection on wind also depends on the wind speed. Slowly blowing wind is deflected only a small amount, while stronger wind deflected more. Okay. In larger scale atmospheric movements, the combination of the pressure gradient due to the uneven solar radiation, which we covered a few minutes ago, and the coronal force due to the Earth's self-rotation causes the single meridional sail, okay, to break up into the three convectional sails in each hemisphere. So first sail is what? The headless sail, this one, and the other one is parallel sail, and the other one is third one is what? Polar sail. So each sail has its own characteristic circulation pattern. Means each sail have its own circulation pattern, circulation of wind. Okay. In northern hemisphere, the headless sail means this sail. This is what? Headless sail. So circulation lies between the equator and the north latitude 90 degree. Okay. So it equator and the north latitude 90 degree. So dominating tropical and subtropical climates. The hot air rises at the equator, okay, and flows towards the north pole in the upper atmosphere. So this moving air is deflected. Okay, so this moving air is basically what? Deflected. When air deflected, if I am talking about as I already declared, the headless sail means circulates lies between the equator and the north latitude 30 degree, and that is basically dominant tropical and subtropical climates. Okay, so coronal force becomes so strong to balance the pressure gradient force. Okay, as a result, the winds are deflected to the west. The air accumulated at the upper atmosphere forms the subtropical high pressure belt and thus sinks back to the Earth's surface. So this type of change in pressure or the gradient, that is basically due. That's the reason to generate the wind. Okay. So north pole flows along the Earth's surface towards the equator near north latitude 60 degrees. The Coriolis effect becomes significant to force the airflow to southwest. So it's little bit difficult, but you can easily understand in this style that uh, if we are talking about the Coriolis force, the Coriolis force is only the reason of the self-rotating of the Earth. So due to the self-rotating of Earth, there is basically generation of Coriolis force. So you can say that in simple words in this style. So self-rotating is important factor of winds generation. So in other words, you can say that the Coriolis force is affect the direction of wind and speed of the wind. Okay, because in our generation side, if we are going towards the turbine, so it's important to analyze the speed and the direction of the wind. So the direction and wind means the speed of the wind and the direction of the wind, it depends upon the Coriolis force. So it's important factor of the direction and speed of the wind. After that, third one is basically local geography. So it's clear from words local geography. So basically on Earth, there is the roughness on the Earth's surface is a result of both natural geography and man-made structures. Okay, means triple, fourth, or fifth, or seven, eight stories buildings and other man-made some structures, and there are also natural structures like mountains. So the frictional drag and obstructions near the Earth's surface generally basically attend with the wind speed and induce a phenomenon known as wind shear. That's known as basically what? Wind shear. And the rate at which wind speed increases with height varies on the basis of local conditions of the topography, terrain, and climate. With the greatest rates of the increase observed over the roughest terrain, a reliable approximation is that wind speed increases about 10% with each doubling of height. It's proved from the research. When means if you double the height, the wind speed increases 10% at that double if you double the height. Okay. So in addition, some special geographic structures can strongly enhance the wind intensity. For instance, wind that blows through mountain passes can form mountain jets with high speed. So there are basically main three reasons of wind generation. So this is basically recap of the lecture. How does wind form? Means in this how wind forms basically due to the change in the pressure gradient or temperature. So due to that, basically winds forms when air move from high pressure to lower pressure, and that is basically the movement or the motion of air is known as basically what? Wind. So second one is basically this is the recap of this whole lecture. So wind generation. So wind generation is due to uneven solar heating. Uneven solar heating is due to different reasons. Let's suppose um, sun direct hits on the equator, and at the poles there's a basically different in uh, pressure or temperature. So that is basically due to the uneven solar heating, and some other reasons. There is basically self-rotating of the Earth. It's called tilt axis 23.5, I think so. And after that we have uneven solar heating. There's basically difference in like vegetation, rocks, ice, snow. So at the snowy area there is basically low temperature, and at the deserts there is basically high temperature. So there is basically change in pressure and temperature. So that's why basically these are the reasons of uneven solar heating. So that's why wind generates. And after that we have current force. Current force is directly affect the speed and the direction of the wind. Means the direction of the wind is from north to south or south to west. So that is basically due to the current force. And after that we have local geography. In local geography, basically we have natural geography and as well as man-made structures which affects on with the wind generation. So that's all about this today's session. So we cover how does wind forms and what are the reasons of wind generation. If you have any question or queries, then you are more than welcome. Okay, guys, thank you. Allah Hafiz.